Hello. Since the previous panel lines video, I've had some requests for how it works on curved surfaces. There's several concepts overlapping here, so to try and stay on topic, I won't be covering things like how the knife tool works or the various ways of cutting holes in cylinders. There's loads of videos already covering those topics. The reason you would use this technique is to make normal maps, which again, to stay on topic, I won't be covering here. Over in Blender, I've changed the viewport shading to a matte cap so we can easily see what's happening, and I've set up several base objects that we're going to be working on. These are nothing fancy: a beveled cube, some cylinders and a UV sphere. In the background, I've also set up a holder object that I'm going to use to copy the modifier stack from. This is set up with 3 modifiers: edge split and turn off bi-angle, solidify set to 0.5, even thickness and only rim, and lastly a bevel modifier set to 5 segments and adjust the amount as needed. One last thing we need to understand is the concept of form. I'll be doing a video on this soon, but for now understand that each object is there to represent the already established form of what you would be working on. We're using cubes, cylinders and spheres, but it's no different to if your object's form was the surface of a wing for an aircraft. You have that form already, and we're adding lines to the surface with any of the normal ways we have at our disposal for doing that. So we can use edge loops, the knife tool, knife project, loop tools, the shrink wrap modifier. You can also use booleans, but the cleanup required for this technique is not worth it. Booleans are best used for establishing the form. We'll start with simple examples and get more complex as we go. First, let's add some loop cuts around the middle sections of our cube on all 3 axes. Now if I select those lines and mark them sharp, I can copy over the modifiers by shift selecting the holder object, then press Ctrl L and copy modifiers. We get a nice panel line. The curved edge of the cube really makes no difference here. We can now do pretty much anything to the lines on the surface of this cube and have them act as panel lines. It can get messy if your cuts are too close to existing geometry, as the bevel will either clamp or overlap, causing distortion, and similarly it's why we use a low amount on the solidify modifier. Moving on to a cylinder example, we again need to think about it in terms of form. Cylinders shade properly when the loops are evenly spaced. Even without moving them, if you were to add lots of loop cuts in one area, it will start to break the shading and give you a faceted look. Even if you were to use Edge Curve Plus, it still breaks it. The only way to avoid that is to either add them evenly around the entire cylinder or confine it to one area with an inset. The top of the cylinder is an n-gon. We can leave it as it is, inset it or grid fill it depending on what sort of topology we want there. But the technique is the same: use the lines on the surface to determine your panel lines for whatever design you want. You just can't add unevenly spaced loops, as we've just seen. This will break the shading. If you need a vertical edge, confine it with an inset first. On the other cylinder, I have shrink wrapped a circle to the side, then joined the two together and bridged them. You'll notice from the side the area is concave, and that's because it's wrapping around the cylinder and just filled with an end gun. We can inset and extrude this section and then scale the end to 0 on the y-axis to flatten it out before detailing it however we like. If we look at the bevel modifiers geometry tab, specifically the mitre outer dropdown, here you can change it from sharp to arc, and what this does is change the corners of the bevel to round like the internal ones. I do think this looks a lot better in most cases, but you'll notice when you use it that there's some shading issues now coming from those corners. The simple fix for this, as I said before, is just to inset it before, and this confines the shading issue to that ring of faces where it's more or less unnoticeable. Lastly, if none of these techniques work, you can always use floating geometry as I did in my simple normal maps video. If you found this useful, a subscribe would be appreciated. Thank you for watching.